Now today, this is a small lecture. 2.5 is really small. So today we will study 2.5, and depending on time, the remaining part we will study 2.6. 2.5 is too small, simple lecture. Here we are going to study some standard terms, some basic terms related to transmission. They are span, sag, corona, and grounding, and there is one more term, Ferranti effect. First is span. Yes, there is some doubt. Okay, coming to span. Span we already discussed. Do you remember when we discussed about the type of support? We discussed if you use stronger supports, we can increase the span. For like the span will be increased if you use instead of wooden span will be less, and for metal or concrete type span will be more. So span actually means, as you see in this picture, we have two supports, and the straight line distance between these two tower is called span. Span is the distance between any two consecutive line supports. Why consecutive is important? Because after this first one, there will be second one, then there will be a third one. It is not distance between first and third. It is between first and second. Consecutive means immediately next. So this two between the distance between two adjacent or two next to next tower is called span. Span is an important parameter because the tower height depends on span. If the span is more, height must be more. If span is less, height can be reduced, because this is the line, transmission line. If as the distance increases, this will go down. It will go like this, and the distance from ground will be less. Therefore, if the span is more, height must be increased. And if you increase the span, even though the height increases, the number of towers used will be reduced, and therefore you have to increase the length. As you increase the length, height will increase, number of towers will decrease. So you have to consider based on the cost. Cost may change depending on number of towers or height, etc. Second important term, again related to the same picture, is sag. Sag also is an important term. Why sag is important is, sag is this distance. First, let me explain what is sag. This is a straight line connecting between these two towers or supports. And the transmission line always, you might have seen that it is always hanging down, not straight. A small hanging will be there. How much hanging is there? That is that slope is actually the distance between the straight line and the lowest point of the actual transmission line is called sag. The vertical distance between the straight line joining the points of support, that is this one. This is the point of support, this is the point of support. So this is the straight line, and that vertical distance from here to here, that vertical distance between that straight line and the lowest point of conductor. This is the lowest point of conductor. So this two difference between these 2 points, vertical distance between these 2 points is called sag. The vertical distance between straight line joining point of support and the lowest point of conductor is called sag. This is an important parameter, because when you make a transmission line, actually here the ground is drawn as straight line, flat ground, but actual ground may not be flat. Ground always will have hills, rivers, roads, buildings, lot of things will be there. So to know the distance from the ground, you must know sag, because this lowest part of the ground must, sorry, the line must be at a minimum distance from the ground. If the ground is like, if it is a hill in between this, here if there is a hill, you have to consider a higher tower, or you have to reduce the distance between the towers. Span, normally we will keep constant span between, or constant distance between each and every tower. If you have this span here, next tower also same span, then next it will go like this. But in some places, if there is a hill or some building or something, this sag, if it goes more than the allowed value, this distance from ground will be decreased. In such cases, you will adjust this span. So this sag and span works together. To keep sag within the limit, you can adjust span. Based on that, you will decide, okay, if you have to transmit from Yambu to Medina, first thing what you will do is you will decide, okay, I will use this size tower. So this, depending on height of the tower, there will be a standard span to be used. For example, 100 meter. So each 100 meter, you will draw a drawing like this, and you will try to make the sag. Each sag also you will draw the ground. If there is hills, etc., that will be drawn. Now you will check all the sag points. Here, if there is a hill, this is the minimum distance. This distance is satisfied or not? Yes. Next. Each sag point you will see, and if there is some point where the minimum distance is not satisfied because of ground not flat, you will adjust the span. Some places you can increase the sag, some places span, and some places you will decrease span. So to decide this span, you will use sag. One more important thing is that is the difference in the temperature of summer to winter. You know, as temperature changes, this size length of the conductor will change. Conductor will expand when there is temperature. So during summer, the line may come down a little bit more because of expansion. And if it is winter, that may become tight. So this difference in sag will change with respect to summer and winter. Like here, Saudi Arabia, not in Yambu, but if you think about temperature in Tabuk or Riyadh, etc., their temperature will go very low and peak 50. So like 5 degree to 50 degree, there will be considerable change in sag. So this difference in sag in difference summer to winter also must be considered when you design a transmission line. So sag as well as span, these two are important terms related to design of a transmission line. So you are selecting conductor, you are selecting tower, you are selecting insulator. Along with that, these are the materials, but when you make the towers, you have to consider these two important terms, span and sag. How many towers you need, what will be the distance between them, this is decided based on, actually it is span, but the span is decided based on sag. Okay, these are the two important terms. Next comes another important thing. This we discussed before. Someone asked me even in the class when we had a normal class, that is corona. Corona is a special effect happening in transmission lines. Normally we don't see it here. It is normally seen in the places where there is snowfall, etc. This is happening in some transmission line, especially in high voltage transmission lines. Just I will give you definition first, then we will discuss. It is a phenomenon of violet glow, hissing noise, and production of ozone gas in a overhead transmission line. So this transmission lines will be at high voltage. when this high voltage exceed a particular voltage which is called critical disruptive voltage, there will be some conduction happening inside air. Air is not a conductor, but inside air there will be water and other type of impurities. These impurities will make air conducting, but not conducting between the lines, but it will make a small circulating path of current inside air. This will result in ionization of air. Air will become air molecule, or ion in these molecules will become ions, positive charge and negative charged molecules or ions, and this ionization will result in small circulating current produced surrounding the transmission line. This ionization will happen when the voltage exceeds critical disruptive voltage. But this critical disruptive voltage is not a constant. Critical disruptive voltage depends on the quality of the air. If the air have more water molecules like in snowfall, critical disruptive voltage will decrease. Normal our case here all it will be well above the transmission line voltage. We are 380 kilovolt, that is our maximum voltage, but the critical disruptive voltage of air in our area will be even more than 400 kilovolt or even more than that. That's why this corona not happening in our area normally. But if there is snowfall or more humidity and this type of some more chemicals in air, such special cases, critical disruptive voltage will go down, and the light it will may go below the transmission line voltage 380 kilovolt in our case. If it go below 380 kilovolt, now actually what happens, the line voltage increases critical disruptive voltage. This will result in ionization of air, and there will be some ozone gas produced, some hissing noise because of this circulating current will heat up the air. Also, because of this ozone gas production surrounding the transmission line, there will be a violet glow. This is called, this process of producing that violet glow color, hissing noise, and production of ozone surrounding the transmission line is called corona. Actually, I couldn't put a picture here. Just Google it, corona on a transmission line. You can see very beautiful video with this violet colored transmission line, especially in these snowy areas. This happens normally in snowy areas. Again, if there are this critical disruptive voltage goes below the transmission line, and again if the air have more water and more pollution, this type of things, this after critical disruptive voltage there is another voltage which is called a breakdown voltage level. If this voltage breakdown voltage level also comes below the transmission line voltage, there will breakdown or flash over will happen. That we have two lines passing through two sides of the transmission line. So from phase A to phase B, there will be flash, like lightning happens, there will be flashing between the lines. This also may happen if the air is that much polluted and more water content and more chemical content comes in air. That's a special case, but even air may lose its insulation property between these lines, and because of this very high voltage, this is actually high voltage 400 kilovolt or 720 kilovolt higher voltages, and there will be short circuit happening through air between the transmission line, that is called flash over. There will be arc produced between the lines. So this is the extreme case of corona. Now, what are the factors affecting corona? As I told you, the first thing is atmosphere, because critical disruptive voltage depends on the atmospheric condition, because air has to ionize. So this ionization of this corona depends on the atmosphere. That is, if it is a stormy weather, number of ions will be more than normal, and therefore more corona will be produced. Another important term is conductor size. This corona depends on shape and condition of conductors. A rough and irregular surface will give rise to more corona. You remember when we talk about the conductors always will be stranded, right? Many small conductors twisted together. When you make this more conductor twisted together, its surface will be irregular, not smooth. If it was a one conductor, surface will be pure circle, right? Smooth surface. But when you make this twisted conductor, surface will be irregular, so it may give rise to more corona. So here the stranding is giving a negative effect, but because of flexibility and strength, always we will use more twisted. But what we can do is, here the special cases where there is corona, we will use special conductors. Then another thing is spacing between conductor. If the spacing between two conductor is less, chance for breakdown is more. So these places where there is chance for corona is there, we will increase the distance between conductors. We know the places where this corona will happen, that where snowfall and such places. So there will be a normal standard distance between the conductors, but in case of these corona places, we will increase the distance. So if the distance is less, chance for corona is more. And of course, the last point, that is line voltage. If like here, our maximum voltage is 380. So with 380, that this critical disruptive voltage has to come down below 380. So it's a rare chance. So getting corona is less. But if our voltage was 760, then critical disruptive voltage may come less than 760. Then we have a chance for having more corona. So as the line voltage increases, chance to have corona is more. So these are the four important parameters which determine corona: atmosphere condition, conductor size, spacing between conductor, and line voltage. Now comes to the last point in this factors or some terminologies. We study about span, sag, and corona. Another important effect which is happening in transmission line is Ferranti effect. This Ferranti effect is a special case. Normally, when you transmit power from one place to another place, it is passing through the conductor, right? When current pass through the conductor, what will happen? There will be voltage drop. So if you send at, for example, 100 kilovolt from Yambu, by the time it reach Medina, its voltage, because of voltage drop, voltage will decrease, and when the time it reach Medina, we may be getting maybe 95 kilovolt. 100 will reduce to 95. This is what is actually normally happen because of line resistance and inductance. Normally we talk about line resistance only, but transmission lines have not only resistance. Transmission line have resistance, inductance, and capacitance. You know about inductance and capacitance. Inductance will be the current, the voltage because of inductance will be lagging the current, and voltage because of capacitance will be leading. So it's not just adding, it will be adding like vectors, like you see in this picture. So here there is receiving end voltage VR. With that, you have to add IR and IR and IXL. When you add IR and IXL to this transmission line, receiving end voltage, actually because of this vector direction, you see the sending end voltage Vs will be less than Vr. What is Vs less than Vr? Sending end voltage is less than receiving end voltage. So if you send at 95, sorry, if you send at 100 kilovolt from Yambu, by the time it reached Medina, it increased to 110. 100, how it will become 110? This is a special case if there is more capacitance for the line. This is because of the capacitance of the line is higher. So this is a special case. This special case is called Ferranti effect. This happens only in long transmission line. So in long transmission lines under light load, when there is load less, the sending end voltage of the line become less than receiving end voltage. So receiving end, you will get more voltage because of the capacitance of the line. This effect is called Ferranti effect. So the long transmission lines under light load condition, sending end voltage of the line become less than receiving end voltage. This effect is called Ferranti effect.